Section 9.2, two means, independent samples. Two samples are independent if the sample values from one population are not related or somehow naturally pair or match with the sample values from the other population. Two samples are dependent or consist of matched pairs if the sample values are somehow matched, where the matching is based on some inherent relationship. In this section, we will learn how to conduct a hypothesis test of a claim about two independent population means. We also learn how to construct a confidence interval to estimate the difference between two independent population means. Mu1 is population mean, X bar 1 is sample mean, sigma 1 population standard deviation, S1 sample standard deviation, N1 sample size for the first sample. The corresponding notation mu1 as the corresponding notation mu2, sigma 2, S bar 2, S2, and N2 apply to population 2. Requirement 1. The values of sigma 1 and sigma 2 are unknown, and we do not assume that they are equal. 2. The two samples are independent. 3. Both samples are simple random samples. 4. Either or both of these conditions are satisfying. The two samples are both large, with N1 is greater than 30 and N2 is also greater than 30, or both samples come from the populations having normal distributions. There are two ways to determine your degree of freedom. The simple one, we just use the smaller of N1 minus 1 or N2 minus 2. Which value is smaller, we are going to use that one. Or we can use the more complicated one. However, you don't need to actually calculate it. Your calculator or StatCrunch will give it to you. Example 1. Listed below are student course evaluation scores for courses taught by female professors and male professors. Use a 0.05 significance level to test the claim that the two samples are from the populations with the same mean. Does there appear to be a difference in the evaluation scores of courses taught by female professor and male professors? I am given two different samples. One is the female professor scores, and the other one is male professor scores. I will call this group 1, and this is group 2. Use a 0.05 significance level to test the claim that the two samples are from the populations with the same mean. So basically, they want me to test to see if mu2 equal to mu1. My original claim is mu1 equals mu2. If the original claim is false, then mu1 is not equal to mu2. HA is mu1 not equals mu2. HO is mu1 equals mu2. Or I can bring everything to the left side to have mu1 minus mu2 equals 0 for my HO, and mu1 minus mu2 not equal 0 for my HA. HA contains the not equal to, so this is a two-tailed test. Significance level is 0.05. I will use StatCrunch to find my test statistic and my p-value. I have imported the data into StatCrunch. The first column is the data of female and the second column is the data of male. Stat, t-stats, to sample with data, because right now I'm given the raw data. Sample 1 is female, sample 2 is male. For the hypothesis test, HO is mu1 minus mu2 equals 0. HA is mu1 minus mu2 is not equal to 0. This is my test statistic, and this is my p-value. I will round t-score to 2 decimal places, which is negative 0.66. And my p-value is 0.5172. I round it to 3 significant figures. Again, if there are instructions on how to round, please follow the instructions. P-value is greater than alpha, so we do not reject HO. Since I don't reject HO, and HO is mu1 equals to mu2, and HO is also my original claim, that means there's not sufficient evidence to warrant the rejection. Example 2. Use the previous data, construct a 95% confidence interval, estimate the difference between the mean course evaluation score for female professors and the mean course evaluation score for male professors. In this case, they gave me a confidence level, which is 95%. What they want me to do is use the data that they gave me from the previous example to find the confidence interval. I will use StatCrunch for this. To construct the confidence interval for the same data, all I do is just click on here and edit. Choose confidence interval down here and choose the correct level. This is my lower limit and this is my upper limit. And this is what I got for my confidence interval. By the way, if they're asking you for the degree of freedom, this is your degree of freedom for this problem. Example 3. Data on the weights in pounds of the contents of cans of diet soda versus the contents of cans of the regular soda is summarized below. Assume that 2 samples are independent, simple random samples selected from normally distributed populations, and do not assume that the population standard deviations are equal. I have a table here listed the diet soda and regular soda with N1 is 40, N2 is 40, X bar 1 is 0.78257, X bar 2 is 0.80995, S1 is 0.00431, S2 is 0.00758. Question A. Test the claim that the contents of cans of diet soda have weights with a mean that is less than the mean for the regular soda. B. Construct a confidence interval appropriate for the hypothesis test in part A. First, I need to identify my original claim. I want to test the claim that the diet soda have the weight means less than the mean of regular soda. If I call this group 1 and this is group 2, I want to test the claim if mu1 is less than mu2. If mu1 is less than mu2 is false, then mu1 is greater than or equal to mu2. My HO is mu1 equals mu2, and HA is mu1 is less than mu2. Or I can have mu1 minus mu2 equals 0, or mu1 minus mu2 less than 0. Significance level is not given here. That means I am going to use 0.05. My HA contains less than, so this is a left-tail test. I will use StatCrunch to find my test statistic and my p-value. Stat, t-stats, to sample with summary. In this example, I'm given the summary instead of the raw data. This is where I put the information from sample 1, and this is where I put the information from sample 2. Sample mean, which is x bar 1, 0.78257. Sample standard deviation, S1, 0.00431. Sample size N1, 40. X bar 2, 0.80995. S2, 0.00758. N2, 40. HO is mu1 minus mu2 equals 0. HA is mu1 minus mu2 less than 0. This is my test statistic, and this is the p-value. In here, they don't give me the actual p-value because it's very small. So all it tells me is that p-value is less than 0.0001. And this is the degree of freedom, just in case you need it. I will round t to 2 decimal places. And p-value, they say that is less than 0.0001. P-value is less than 0.001, which means it's also less than 0.05, which means I will reject my HO. So HO says mu1 equals mu2, and I reject it. That means I believe that mu1 is less than mu2. That means I believe that the diet soda have mean weight that's less than the mean of the regular soda. B. Test the claim using confidence interval. First, I need my confidence level. I need to use the fact that this is a left-tail test and alpha is 0.05. For a left-tail test, my confidence level is 1 minus 2 alpha, which is 1 minus 2 times 0.05, which is 0.90. I will use StatCrunch to find the confidence level for mu1 minus mu2. To construct the confidence interval for the same problem, I'll just edit it and choose this one and change my level to 0.90. Compute. This is my lower limit and this is my upper limit. If there is an instruction on how to round these two numbers, please follow the instruction. In this problem, there was no instruction on how to round, but X bar has 5 decimal places. I will round my confidence limit to 5 decimal places. This saying that we are 90% confident that the difference of the two means fall into this interval. HO says the difference of the two mean is 0. While this interval is from negative 0.0968 to negative 0.02508, they both are negative. That means it does not contain 0. When your confidence interval does not contain 0, that means HO is rejected. And the conclusion should be similar.